So, all right, guys, let's open up. We are doing lesson 22. That is your page number
22.
Well, so we're gonna review one piece of last week's.
What page?
It is on page 614 was last week's. So we have a YouTube video that we will watch and see if we could remember all of these things.
What, 6, what?
14, 614.
Wait, so this page?
Yes. So now remember, we were doing these. Let's see if I could. All right, here we go. Is this on there?
Yeah, it is.
No, I'm trying to get it on there. Okay.
It's
So,
there.
I'm gonna hit this button here, right? Okay. And then we are going to hit this button here. All right, so now we're listening. Ready? Okay, and we're playing. Okay. So this is a review of last week's. Remember Claudius?
Kind of hard to forget his name.
Yes. Remember Copernicus? And Galileo? Galileo and Kepler. Remember all these astronomers?
Johannes Kepler.
What is that a picture of?
Milky Way.
Models are
Milky
represented.
Way.
Which is what
Nations
we
of
would.
planets in their orbits around the sun, and were formulated by tracking planetary and stellar orbits observed through telescopes.
Who advanced the telescope? Do we remember who advanced the telescope? We went from,
Galileo.
yes.
He's the one. Want me to just turn the light off now?
I don't want anyone sleeping.
The
Hey,
geocentric
so look
model
at
is
this.
the geocentric model
Look at
of
this
early
part. This is
significance
the
as regards to the
geocentric
function of
model
various aspects of
versus
astrophysics
the
as well as understanding of
heliocentric
the
model.
universe.
Remember that? Do we remember which one was the geo, Ash? What was in the center for the
Until the 15th century,
geocentric
it
model?
was believed that the sun and the other
Was it
planets
the sun or
revolved
the
around
Earth?
which
For the-
remained
For
stationary.
the
This was based on the
geocentric,
concept
Earth.
of geocentrism.
What about the heliocentric? Put out.
For about 2,000
What else?
years, the astronomical models proposed by Aristotle and Ptolemy were thought to be accurate representations of the planets and their orbits.
The heliocentric?
You don't know?
No.
There's only two. Earth and Sun.
And what did helo mean? What
Just
did
said Earth.
helo mean? It was a
Sun.
prefix that we had
Sun.
worked on.
The sun,
The sun. Because what did centric mean?
Earth,
The center, remember?
and then,
Remember we were putting the words together?
and then the other
Earth?
would be Earth.
Why are you glitching?
Okay, so here's the geocentric theory.
There's
See the
Sun,
Earth in the
Moon,
center?
Mars, Jupiter.
This is what the geocentric theory. It was believed that the Earth was the center of the universe. That the sun and all the planets believed to revolve around and orbit the Earth. And this was believed, two common observations. Heavenly bodies revolved around the earth on a daily basis, and the perspective of earth-bound observers, that Earth was fixed in space, which was about, I think, 1,400 years according to our book, until the theory was challenged by who? Who was the theory challenged by? Do
The
you
circle
remember?
defines the planet's orbit as
Galileo. And do you remember he
the
also
plane moves
was
in along the epicycle,
summoned to
while the center
court
of the
because of
epicycle moves in
such?
steady circular motion around
Remember?
the center of the disk.
And what else happened to him?
He was never allowed to make a book.
That's right. He was not allowed to write any of his theorems in the books because of such. So it says, on the 16th century, new models were devised by Copernicus. Nicholas. So here's when the geocentric, there we go. So, yes, being seen from the, did you see that? The center of the sun. The heliocentric model, the model purposes the sun as the center of the solar system.
Which is true.
Which is true, yes. And so the earth, there it is. There is an image of what it looks like. The heliocentric model. See the earth? See the planets?
And it's weird how they have.
We are orbiting around the sun, right?
That was the
Let's
second
go.
Hmm?
Go grab a piece of paper and show you some.
The sun orbits around all of us.
one.
Hmm?
It's like off.
Well, is the sun the center?
Nope.
The sun is near the center of the universe. The idea of the halo all right, there you go. There is a look. That is the sun in the center. So who is orbiting around? The planets? See that?
Here comes a review
Stars.
of these two models.
Look at that, Josh. Look at the
Overview.
those are the
The
two
planets
systems.
go in a circle while the whatever's in the center is spinning.
Well, what's in the center now? That we know
Sun.
of? Sun, right.
This is those.
Yes.
Those are the sun. It's weird that
So at one point we thought that the earth was stationary. We were wrong. We were wrong for about 1,400 years.
it's weird that for Venus it has that.
Which is what? Isn't that like a female?
No, but for look.
So this is all information that we went over last
Pretend
week.
this here is Venus.
Pay attention to this.
On
video.
the thing on the screen there, it was showing this. Look. It was showing this.
Okay, so that is a recap of
Right there.
that is a recap of our last week. The geocentric, the heliocentric, the different astronomers. Remember?
Yeah.
Okay. So now we're gonna move into
The book.
the book. Now we're gonna move to lesson 22.2. And yesterday I had you go over the definitions. And
I remember all of
today we are gonna go over the definitions.
So 22.2.
Because we're gonna spend some time. Are you listening, Josh?
Is it 22.2?
Okay. Yes,
I remember
and it
one of
is
them.
on page 622. So this section is called the Earth, the Moon, and the Sun system. All right, who wants to, let's go over our first definition of rotation.
I have 5 more.
What is rotation? Josh,
The main.
Something rotating.
what is it? What do you think the definition of rotation is?
The main.
What is rotation? What do you think it is? Huh? If it's rotating, what's happening?
The rotation of Earth.
Yeah, so what's happening?
It's moving.
What is it doing? Is it turning?
It's rotating.
Yes, so what does rotating mean? Is it turning? Is it spinning?
It's just rotating.
Do you think rotating means turning and spinning?
Rotating means
What do you think, Josh? Rotating, does it mean turning and spinning?
I guess.
Yes, okay, so is that going to be easy for us to remember?
Yeah.
Rotating,
I remember
turning and spinning, right?
I remember winter.
You remember which one?
New Year's.
Okay, good. All right, what about revolution? Does anyone remember the definition for that one? Revolution is the motion of a body, such as a planet or a moon, along its orbit around some point in space. So an example would be Earth revolves around the sun, and the moon revolves around Earth. Earth also has another very slow motion. A very slow motion is called precession.
I thought that was weird because orbit's not moving that fast.
Well, what is orbit?
Orbiting.
What did we say? Wasn't orbit one of our
Say
words last
something.
week?
That's spinning while it's going around the center.
Yes.
Yeah, but orbit is also just.
It's more like, look, here's the sun.
I just remembered I'm supposed to be in here. I'm sorry, Rebecca.
You're fine. You're fine. Go ahead. So what else?
There's the sun here. And here's another. It goes. like this
Gabby, how are you, honey?
in a full circle around. the
Okay.
sun.
All right. So
That is what
orbit.
orbit
All right. So let's open up to
is.
page 622. And
Yep.
Ash, do you want to start at motions of Earth? Now we're going to go over the first
Yeah.
three terms that we've already just discussed. Okay, go ahead. Rotation.
Try something else.
Mm-hmm.
Rotation is the turning or spinning of the body on its
Axis.
axis.
Mm-hmm.
What page are you on?
We're on page 622.
Revolving is the motion of the body, such as a planet or moon, along its orbit around some points in space. For example, Earth revolves around the sun, and the moon revolves around Earth. Earth also has other very
Earth also has another very
another very slow motion known as
precession.
precession, which is a slight movement over a period of
Oh, you skipped the line. Which is the slight cone-shaped movement.
I don't have cone shape. We should have slight movement.
You don't have cone shape. Okay, so I'm on a newer version of a book. So in the new book, it says cone shape. Go ahead.
Slight movement over a period of 2.
Yeah, mine does not say that.
A period of 26,000 years of Earth's
Okay,
axis.
precession. Okay, so
Yours
what
doesn't
mine
say
says is, it says cone-shaped movement of where in the sky, Earth's access points.
Hey, I'm just gonna scoot over
The
here.
period of Earth's rotation is 1 day. No, I do know this is a newer book. However, the period of Earth's precession is 26,000 years. Alright, so, rotation, go ahead, Cordell, you're up.
The
Rotation,
main results of Earth's rotation are day and night. Earth's rotation has become a standard method of measuring time because it is so dependable and easy to use. Each rotation of Earth around its axis is equal about 24 hours.
okay, so, what is 24 hours?
Full day.
Full day.
What is that? In my
Full day
Full
and
day.
night.
Go ahead. The result?
What? I have no idea where I just left
You
off.
lost the spot.
I've lost my
Look for where you had 24 hours.
Okay. You may be surprised to learn that we can measure Earth's day in 2 days. Most familiar is the part.
Oh, okay. So you stopped at 24 hours, yes, and then you said you may be surprised to learn that we can measure Earth's day in 2 ways.
In 2 ways.
Most familiar is the apparent,
Solar day. The time interval from 1 noon to the next, which is on average about 24 hours noon.
24 hours period, so let's stop for a second and then go noon.
Is in the
Is when?
sun. Is when the sun has reached its highest point in the sky for that day.
Mm-hmm.
The
Side rail?
sidereal day, on the other hand, is the time it takes for Earth to make one complete rotation, 360 degrees.
Okay, stop 1 second. What is 360 degrees? We know what that is?
Full 360,
What is a full 360? A full
like
turn?
this.
Let me see. Okay, a complete turn, right? Complete turn? Alright,
Like
let's remember that for math. Okay, moving forward. With respect.
respect to a star another than our sun.
Is our sun star? Is our sun a star?
Another
Huh? Is our sun a
Star.
star or a planet? Josh,
No.
is our sun a, hold on 1 second.
with
Production.
respect to a star other
It's not a planet.
than our sun. The sidereal day is measured by the time required for a star to reappear at the identical position in the sky where it was observed the day before. Identical
Okay, so
observed
let's
the day
wait 1 second,
before
Cordell.
the
Cordell, when I say let's wait 1 second, that means stop, okay? Alright, let's go back and reread that sentence. The sidereal day is measured by the time required for a star
the
to
huh?
reappear at the identical position in the sky.
The
Where
sidereal
it
day
was
is
Cordell.
measured by the time
Cordell?
star.
Cordell.
Okay, now I lost my spot. In the sky where it was observed the day before. So we talked about a complete turn, right? That was the 360
Just
degree.
like of
So do you see? Uh-huh. So, alright. So now it's talking about and then the identical position in the sky where it was observed the day before.
the
So that's why earlier they were saying that time is dependable and easy to use. They're using that as a form of measuring. Okay? Alright. Go ahead. I'm so uncomfortable.
the sidereal day, it has a period of 23 hours, 56 minutes, and 4 seconds.
So
Measuring
That is.
in mean solar time, which is almost 4 minutes shorter than the mean solar day. The difference results because the direction to distant stars daily change because of Earth's slow revolution along its orbit. The direction of the sun, on the other hand, changes by almost 1 degree each day. This difference is shown in figure 12.
Yeah, so where is figure 12? It's on the bottom of the page. Mm-hmm. Right here.
Apparently, it's like the sun just moves 1 little centimeter. 1 centimeter. 1 degree.
1 degree. Okay, so it says figure 12, surreal day. It takes Earth 23 hours and 56 minutes to make 1 rotation with respect to the stars, the surreal day. However, after Earth has completed 1 surreal day, point Y, where's point Y? Here. You see point Y? Here's point
No.
Y, here's point Y. Here's day 1, here's day 2. You see it?
Oh.
Point Y has not yet returned to the noon position. Where's the noon position? Look at how it is on day 1, look at how it is on day 2.
Oh, they're different.
They're a little bit different, yeah.
The line went from like this. This comes off.
Yes.
The line went from being straight to a little slanted.
So a little slanted, yes. So here it says Earth has to rotate another 4 minutes.
And
To
then as
complete.
it goes around, it starts